Hello, in this course we will learn servo and stepper motor control with S7-1200 PLC. We will use pulse and direction signals for step and servo motor control. To use this method, the PLC output must be transistor. Relay outputs cannot perform fast switching operations. We will use S7-1200 DC-DC-DC and KTP400 basic operator panels in our training. Here our PLC S7-1212 DC-DC-DC. So the last DC code indicates that PLC has transistor outputs. Here we have Siemens HMI, and we will use these in our course. First, we will work with stepper motor. The stepper motor chip, but simple control units. There are no feedback signals. With the switch on the step motor drivers, we can adjust the current settings and the number of pulses required for one revolution. Normally, our step motor have 200 pulses for one revolution, and we can use this micro step function for more pulse. The stepper motor driver have pulse, direction, and enable inputs, and this input is 5 volts. Because our PLC outputs are 24 volts, we need to use 2200 ohm resistors when making connections. Here you can see I make it some cable with resistance. And servo motors. Servo motors are available in many brands and models. It's Panasonic, Allen Bradley, and Siemens, Delta, and more. In this training, we will use a Panasonic servo motor and Panasonic servo drive. Servo motor drives and motors have more advanced features, so we will need more cable and more connections. We will explain these features later. We will use servo motor after we have finished our work with stepper motor. Now let's do the connections and start programming. I open TIA Portal software and I start create new project. I give name Udemy Servo 1 and I push create button, and I will use project view. Here is the project view, and first of all we can look which device we can connect. Here I come and I push update accessible device, so I can see which device I can connect or which device I have in my network. Here I have PLC 1 and this is device IP address. I can look inside this PLC, and here I can see online diagnostic, program block, technology objects, and PLC data types. So I want to connect this CPU and I want to use this CPU. We can look in online diagnostic or CPU article number, here or CPU article number, and we can see here firmware. So I must add my project this firmware and this article number. And now I push add new device, and here I come CPU 1212 DC, and here my device article and I can choose different version. My version 4.2. So I choose this device. Here you can see description, and here you can see these 4 pulse outputs on board. So we can use these pulse outputs. I push OK button and TIA Portal adds my device here. This CPU have, you can see, left side 3 and right side 2 module, and I can install or I can add 3 communication module in left side and 2 different module in right side. Here my device. First of all, I must change device Ethernet address. Double click this device and I come here, Ethernet address. So I want to give the same address and 0.20, and everything is okay now. I can try to download the device. Every time if you change something in hardware or if you change something in these properties, you must download hardware and software. And I tried to download here my interface Realtek family controller. I push start search button. You can see here font accessible device PLC 1. I push load button. First of all, this will look inside and this will say me you want change or not change. Here you can see inside have some program or something, and I say continue without synchronization, and here I say stop my control unit and I push load button and this will be finish. Okay, they say you want to start your system. I say OK and finish. Now I can come and go online. I push go online button. You can see everything is green. This means we don't have any problem now. Okay, when we want control servo or step motor, we must use technology objects. I come under technology objects and I push a new object button. So here we have to choose. One is motion control and another is PID. We will use motion control, and this under motion control we can choose 2 systems, to position axis or to command table. First of all, we will use to position axis, and here we can give name stepper 1. I give name stepper 1 and I choose to position axis. This here motion control commands have version. You can choose this version. When you choose this version, this command will change. So we will use last version and 6 and do position axis, and I say OK. So here TIA Portal will be add 1 technology objects and name is stepper. Here we don't need. Okay, these basic parameters and this general. This general have access name, and here ask us drive. We will use pulse train outputs. If you have another systems, you can use analog drive connection or you can use profit drive. This will be maybe after we will make new course, and this course we will use this profit drive with V90. So the unit of measurement, position unit, millimeter, meter, inch, feet, pulse or degree. We will use millimeter. If you have another unit, you can choose here your unit. If you change this position unit, this will next drive will be changed. Now we must change pulse generator. I will choose pulse 1. So if I choose this pulse 1, you can see here signal type PTO pulse E and direction B. So we must connect our device. Pulse signal is Q0.0 and we must connect our direction signal Q0.1. So we know now which one cable where we connect. And here you can see enable output. I will not use this signal now. I will tell after you. I must tell you something after I will use this enable output. And this ready input, if our systems or if our servo motor or step motor have ready input, we can use this ready input. When our servo or step motor ready, they can send some signal, and we can take the signal for use or program. And here mechanics. Here pulse per motor revolution. So we need right here some pulse and we will use this program these pulses. So I want to use 400 pulse per motor revolution. And this per motor revolution load movement, according to your mechanical system, you can write here something. I will use this 10.0 millimeter. This is for this. This is because of this is example. If you use real mechanical systems, you can change this load movement. If we choose this position unit, meter, inch, or feet, when we come here, this mechanics, this here will be changed. So permitted direction of rotation, both direction, positive direction or negative direction. I will choose both direction, and here you can see invert direction signal. If you try or if you work your systems, and if this direction is wrong for you, you can choose this invert direction signal. When you choose this invert direction signal, your direction will be changed. And this here position limit, we will not use this now. And this dynamic, we can use dynamic. Here, this maximum velocity. If you want more speed, you can write here more value, but here I write I will not change this 25,000 pulse second, because this is enough for me. And you can see here acceleration and deceleration. If you want your system stop quickly or change speed is quickly, you can set this value little. For example, 1 second. Here is 1 second. You can see here acceleration and deceleration value. This jerk I will not use now. And emergency stop, you can use emergency stop as 1 second. And this homing we will use after, I will not use now. So my system is ready now. Okay, I will download to device, hardware and software only changes. Okay, we can look here again. These systems here, and I make some picture. Here you can see here are connections. First of all, we will adjust one revolution pulse and motor current, and here power supply we will connect it, and here we will connect stepper motor cable, and pulse signal, direction signal, we will not use this enable signal. I said I must tell something about this. And here or 24 volt DC or PLC outputs. Let's making connections. Okay, our connection is ready now. We can see here, or you can see here, our step motor, and here have one line, and we can see how much our motor turn. And now I start go online my systems. First of all, we will not write some program. First of all, we will use commissioning system. Commissioning for control or step or servo motor with some buttons or with some parts. And here I say yes. And here I can see my system is now ready. I push enable button. I will give power my systems. Now everything is okay. Okay. The jog command give our system is backward or forward. We can write here some velocity, and we can here write some acceleration, declaration. So our motor will run when I push forward or backward button. I push forward button and I push backward button. So my system work very stable, and we can use positions, and this here position, and we can give target position, and we can use absolute or relative commands. You can see here absolute is not usable now because of we don't know home. We don't know homing position now. First of all, we must give home position in our systems. Hi, our system is ready now. We make connections, and we can see here one line. According to this line, we will see how much our motor move, and we will not write program now. We will use commissioning systems for first movement or stepper motor. And when I push these buttons, and here you can see is some part of technology objects. I push activate button and I say yes. Monitoring time 3 seconds. And now here you can see I have some button. I say access enable, so I can use now my technology object, or I can use my stepper motor. This jog common system here have velocity. I can give velocity here. I can give acceleration and declaration, and when I push button backward or forward, my system start working. I push forward button, you can see I will put here my video. I will try to put here. Okay, and I can activate this forward. You can see my motor turn right and turn left. So here my all connections is okay now, and I can use this system here have positioning, and I can give here some position, and I can say go this position. Here you can see absolute and relative buttons, but absolute is not working now. Because this absolute is when we push this absolute button or motor go position, so we don't know now or zero position. Because of this absolute button is not working now. First of all, we must make homing. This homing, it have two buttons, the set home position and homing. We will not use homing now. If we say this set home position, you can see now this our position to 140, and if I say this home position is 0, and if I push this set home position, you can see this or active position now 0. So now my system is 0, and I can come positioning, and you can see now absolute position is work now. Okay, I make now set home position, and I come here position. We will learn how use absolute and relative command system. My system is now position. My system position is now 0. So we write our system. We say 10 millimeter. If my motor turn one revolution or move one revolution, my system go 10 millimeters. If I write target position 10 millimeter and say absolute, my motor must turn or must move one revolution. I push absolute, and you can see my motor turn one revolution or one tour. So if I push again absolute button, you can see my motor is not move, because I say this 10 millimeter go absolutely. If I push relative buttons, you can see here my active position is 10 millimeters. If I push relative, you can see my motor go 10 millimeters. And again I push relative, you can see go again 10 millimeters. And if I push again, you can see go 10 millimeter again. So if I use now absolute button and my target position is 10 millimeters, my motor will turn back and come 10 millimeters. I push absolute button, and you can see my motor turn 10 millimeters. If I write here 5 millimeters, my motor must move half revolution or half tour. I push absolute, and you can see my motor turn half revolution or half tour. And if I push relative, you can see again half turn. So I can control my motor now. I can control my position now. So I can write here some velocity. Now I can write here 10. What happened? We can see 5 and 2 and 1 and 0.5. You can see I can write everything here. If I write here 5, and you can see I will say relative positions. What then? You can see here. What is the parameter of motion in weld? So here we can look our system. Here this dynamics and general, you can see our velocity must not little than 25. In our settings, you can see here we cannot write our velocity lower than 25. Because of this, our system not work, and we cannot write higher than 625. So let's try this, and I can say enable, and you can see our position is now again, we must make home, set home position. So here if I write this 700 velocity, my system again not work, you can see. And if I look under here, you can see our velocity parameters not greater than maximum velocity. So we can write velocity 25 and 625. So I can write here 50, and I say my position is 50, and this can move. So here we have enable signal. Because of this I cut this my system power, because my system give power all time my step motor. Because of this my step motor very hot now. If I will show you something, I come here and main organization block 1, I will write here some little program, and I will say memory 10.1. Here I will write my enable signal Q0.3, and here name tag, and I will write step ready. Okay, I will do land. Okay, give connect energy. Here we can watch. Now my step ready signal is false now. I will come here and activate my system. In enable I will use jog signal. You see my system work now. I will come my main organization block, and I will enable this step ready signal. Now I will try to move my motor. You can see error, and I will check my cable now. We write something wrong because already this Q0.2 must be. I will say rewire tag. I will change this 0.2 and do landing my program and load. Okay, let's start now. Try to move our stepper, activate and enable. You can see my motor not move now, and now I will false this signal, and now I will try again, enable and try to move. You see, our systems enable signal work when this 0.2, if 0.2 is true, my system is not work. If 0.2 false, my system work. So we will use after this signal for our systems. Now this commissioning system here work like this. You can try this part. You can try this commissioning for your connection is okay, or your pulse signal is okay, or your settings okay. If you don't know this, you can use this commissioning systems test all these things. Okay, let's start learning some command. Here this commissioning unit, I will close this commissioning because we will start write some program. And I say go offline now, and I come instruction. So we will use this motion control instruction, and this motion control instruction have some commands. We will use these all commands in our course. First command is the power. Is power. I make some picture here, and this power and reset. Okay. This the motion control instruction MC power enable or disable an axis. So all axes must be have this power, and if we want this axis make move or work, this MC power must be on or must enable. So I will put here MC power, and I can give this here different name: stepper power, step power, and here we have this axis. I must choose my axis and stepper 1, and this enable I must give some signal, and when this enable, my axis is enable. When this disable, my axis is disable. So I will give here something. I must give here something. So if we want to make a nice program, or if we don't want make some fault about address, we can use data block systems. I will use data block, and this data block we can write inside all tags. We can set some value, and we don't think which one we write, which one address we use, which one we don't use. So if we use data block, and we can make nice program, and we cannot mix addresses. So I will write here is data. My data block name is data, and I say OK. Here I have new data block. You can see here this name. We can write here everything, and here is data type and start value and retain. I will write here servo power on, and type is bool. So I will come here and I will write here data, and I choose servo power on. So if this servo power on, my system can work. If this is off or false, my system will not work. And the start mode and stop mode we will not use now. We don't need this part now. And another command is reset. And this reset fault or restarting technology object, if we have some fault or technology object, we can restart our system. and this is about or this technology object commands. So if you look this help document, you can see which one fault you can reset. So I will not use this command now. And another we need, I will open another program. Okay, this another command is MC home. I think you will be remember when we need to use absolute command, we set first home position. This command we will use this command now, set home position or give special position for our access. You can write here absolute position of access after completion of the homing operation. So I will use this home here and write name step home. Here I will choose my stepper. This execute or this working, this enable this I will use here set home, again bool. Here I will put some button and data set home. And need the position. I will not use this position now because if I execute this command, I want the position be 0, and if this mode be 0, after you will see if we change the mode what happens. So we will use this command like this. And another command is halt. This halt command stops all movements. If you have some emergency or if you want stop all movements, you can use this halt command. And I will use this halt command, put here, and here I will write step halt X. I choose my access stepper one and execute halt stepper. I'll come here, right here, and halt stepper. So next we will use next absolute movement, or we can use jog. First I want to use jog. Okay, this jog we give some velocity and we have two commands. If I use this jog forward command, my step motor go forward, and if I use this jog backward and my step motor go backward. So I will use this move jog and step move jog. I choose my access stepper and step forward and step reverse. Here, jog forward, we need data and step forward. Our screen resolution is little now. If you have more resolution, you can use double screen, and you can choose your data like this, push and drag and drop. You can use like this, and I want to make it this normally open. And one more thing, I need jog velocity, and if weight in velocity, you can see this must be real. So I will here jog velocity and data type is real, and I will use this here. So my program ready already, and I want the Dolant. Okay. Okay. I go online, and now everything is green. I don't have any problem, and I can monitoring my system. You can see here this power not on, not set home, and stable halt not true now, and here my jog signal. So first of all, we try move our motor, stepper motor. I push, you can see here our video. Okay, now is our power is not ready. You see here, power is not ready. I modify in my forward signal. You can see our step motor is not work. Why? Because I don't give any velocity, and I don't give my power system is enabled. So first I will modify it 0, and this is my signal, and I will give some value. I think you remember minimum for 25 we can give. I give 30, and I give power, and I connect my power. So start the jog. You can see jog signal, and my motor is move now 0 and stop. Reverse. Now reverse and stop. Okay, this work like this, and try to halt, and my system work, and I give halt command now. You can see our motor stop quickly 0, and power off. So you can see this power off, and I will try to now stepper run, modify 0 and modify 1, and this is not working. We must use power for work or technology object. We can use step home command, give our system position. We can use halt command, quickly stop all movements. We can use jog. Forward and backward movements. So here like this we can continue. Now we don't know our system's position, and I try to take this position. Position stepper 1, and this must be real, and I will use move command need data position stepper, and here I will use stepper and actual position we can take position. So I will download my program. And I say reinitialize. So our position is 430 point something, and I will try to use now home, and my servo is not on. I will try set home, must be position 0. Yes, now I will look, this is nothing happen. Okay, I will close my home signal and I give power. After I use set home and look, this is 0. As if this power not enable, my all command is not work. Before this, using this motion control commands must be power on. Okay, this step another command we need. After we will use human machine interface. So which one? We need instruction, and here, and we need move obsolete. So obsolete command, I choose my access stepper one, and here I say I need one obsolete move bottom, and the data type is bool. Obsolete move bottom, and the data type is bool. And what I need, we can look here. I need velocity and I need position. Here I give obsolete velocity, as this must be real, and this is obsolete position, and this must be real. So I can use this here. This is obsolete position, and this is obsolete velocity, and this is obsolete move signal. So I can close this window. I have here my obsolete command. I do landing, load, reinitialize. So here we have obsolete command. I will try to show something. First of all, our power must be on, and must be home signal must be come and go, must be true or false, and I can use now this obsolete command. I will try to show you something here. Okay, this upper side in or a little bit, yes, this upper side we can or position, and down or move obsolete. So I will write now velocity is 25. I will give position is 100. So I want to my motor must go 100 position or 100 millimeters, and we must see video. Okay, I give signal true. You can see my motor turn and come 100 position. Again, if you want, I will give again 0 and I will give 1. You see, my motor is not work now or not move. If I change position, minus 100 and move. You can see position absolutely minus 100. I want to go 0 position and go 0 position. Okay, you can see our 0 position. And another command we can use is move relative. Move relative, I will choose my stepper and I need move relative, the real move, and this will be bool. I need position, relative position, and I need, this must be real, and I need relative velocity. Can use one velocity all of them, but I want to show you something. Because of this I make different, and this here velocity and relative distance or positions, and here relative move. So I can use it now. I load. Alright, yes. Now I must give some value, and velocity I will give 100 or less, 25. Position 50 and move. And 0. Because of this changes data block value, all data now be 0. You can see my servo is not on now. I push on and modify 1, set home position, and now I can use my relative or position now 0. I will give relative value now, and here we can see our position is 50 now. I give again 0 and 1, and our position 100 now. Okay, if I give 0 here, what happened? Modify apparent 0. You can see nothing happened because this is not absolute position. So our command is like this. Another command we will use in on servo motor samples, and we can use now or human machine interface and work this. Next video I will add human machine interface. We will use KTP 400 human machine interface, or HMI. Let's start adding human machine interface. I will choose schematic basic panel and KTP basic. Here I don't. This is enough. I will make simulation after when we use servo motor. I will use real human machine interface, and I say OK. I add one human machine interface, KTP 400. Okay, now I must select my PLC for communication. I choose my PLC and I say next. I don't want to use header, and background color is green now. And I don't want to see alarms, and one page is enough for me. I don't want the button, and I say finish. When I make it this, we will see now this operator panel is ready. I will delete this text, and I want to show you something. And you know our PLC address is 20. If I look at now, and this is 20, and I will look connections here. Okay, this basic color panel is 0.2. Everything is okay now, and I come sequence and start to use some elements. Okay, what I need, first of all, I need one buttons or one switch make our power on. I try to find my power on in data signal. Here is power on. I choose is power on take. Can write here if on is step power on, and here step power off. Okay, my power signal is ready now. And another one, what we need jog forward, or we can, this is text, this power button, and we can use name is jog forward, and we must use events. And I want, when I press this button and set bit, which bit, data block, step forward, and when I want to release, when I release button and reset bit, the same bit, and this step forward. One more button I need, same size, name is job yours, and events, when I press this button, set bit, I can data step rail, when I release the button, I want reset bit, the same bit. So this is okay now. What I need jog. Jog speed or jog velocity, text jog velocity, color we can change. Alright, jog velocity I will give. I want value. Here I will choose jog velocity, and I want to form here like this. Okay, I need one more buttons. This is forming. Let's say set home. Events, when I press button, set bit, I will choose set home. Copy this, and when I release, I want reset bit. Same address, so I can set home. I need one more here. Value, this value will be position. I need position stepper here. And I will do it. Yes, this is position. And change the color text color red. This is here position. And I need one button. This will be obsolete move. And events, press set bit. Obsolete move and release. Reset bit. Same obsolete move. And one more I need here, and this will be obsolete velocity. Here I want to give this. Another one I need move relative. Here copy. One more obsolete position. This is obsolete position. Okay, now relative movement. When I press the button, this set speed and this set speed, relative move, and I release button, add function, preset bit, and here I need two relative velocity, relative velocity, here I can choose relative velocity here. Okay, one more thing I need, relative position. Relative position is here, and now everything is okay. Now you can check our system. I will try to start simulation. Okay, our system is here and ready, and our motor is here. I will give power. You can see here, step power on. I can make it off and on. I will give job velocity. I must give bigger than 20, or I give 30, and absolute velocity 13, and relative velocity 25. So job forward, job reverse, and I can say here set home, and absolute move like this, absolute move. Okay, and relative move, relative position is 0.5. You can see here is everything is work. You can make it like this project yourself, and this is very easy. S7-1200 CPU or S7-1200 system is very good for using motion control systems. And next we will try to control servo systems, and we will use Panasonic servo motor, and we will learn how set a servo motor parameter with Panasonic software. See you next video. Hi, we continue our lesson. Now we start to control our servo motor. You can see here our servo motor, and this is Panasonic servo motor, and here our Panasonic drive. You can see here, and here we have this cable for connection, and we have one USB cable for adjust or servo motor or servo driver parameters. I give power on servo drive, and I connect this USB cable XP terminal to my computer, and we will use Panasonic software for adjust servo drive parameters. You can see I open software, and this software finds this Minas A5 drive, and I say OK, and this communication with the driver, and here our software now. Here we have this trial run, like our commissioning part on TIA Portal. We can try our motor work or not work, and we can try our connections, and we can look our motor use how much current. So we can use this all things. And another brand servo motor have different software. We must use this software because we need a lot of parameters set or adjusting. So if you have another brand servo motor or servo drive, you must find this software. Panasonic have wizard here, setup wizard. What we need first or step. We need first our servo system must be position controlling, and we need set pulse and direction control method. Step 1 parameter, we can say read the factory default, and next. And here we must choose control mode. First is position control, second velocity control, third torque control, and another one full closed control. We will use position controller in this course. Maybe next course we can use velocity, full closed, and torque control. So I choose position control, and next. Here we can look, or we can choose or rotational direction. This is no problem for us because we can change this direction in our TIA Portal software. And I push next button. Here we must choose pulse input circuit. So if we can send 100,000 pulse in second. So we can use this photocoupler input, and I will push next button. Now our signal is like this. We send pulse for position and speed, and we send direction signal. Choose direction. So our direction signal, if high, motor turn one side, and low, motor turn another side. So we must choose pulse train and sign. And I push next. Here our pulse counts per one motor revolution. We can write here according to our mechanical system. We will not have now a mechanical system, so I will write here. I will write here like the stepper motor 200 pulse. After we can change this, and I push next. Now write EEPROM. Here we can see which one we change. Now I must power off my drive. and power on. Okay, we can use auto tuning using the parameter list, using the fit gain. I will push finish, and if you want, we can choose trial run. I will try to show this video here. Okay, first I must say servo on, and or servo on now. And here's some speed, jog speed, and acceleration declaration. And I can push negative. You see our motor turn, and positive. Okay, our servo drive and servo motor is ready now. So we need make program. And after we will make connection. Here you can see parameter read of the driver. I want to show you how much parameter have. You can see here, and this all of list. Our application is very basic, so we don't need to change a lot of parameters. But if you have very high level operation or very high level machine systems, you must use all these parameters. Next video we will start the program. Okay, here we have a wearing example of position control mode for Panasonic servo drive. We can see here connection. It is 50 pin connector or 50 pin socket. We will not use all this connection. We need pulse signal, we need their signal, we need servo on, and if servo on, this is enough for us for this example. You can see here 2.2 kilo ohm resistors here in onboard. Because of this, we will not need resistor, and this one, you can see this pin 1 is have 2.2 kilo ohm, and this is pulse signal. And here pin 2 and the same 2.2 kilo ohm, and we will use this their signal. And here you can see ground. We will connect here our negative voltage, and here you can see common plus. Positive signal is 7, and here you can see 29, and this is servo on input. We will use this all connection. So this is servo on input here, and I have another picture, and I will show you. Okay, here. Now we have green cable. This is pulse signal, and we will connect Q 0.0 or output 0.0, and we have pin 2, and this is yellow cable, the direction signal, and Q 0.1, and we have brown. This brown cable is negative voltage, the pulse signal negative voltage, and pin 6, and this is white, and direction signal negative voltage, and pin 7 is red cable, and this 24 volt DC positive signal, and pin 29 this blue and servo on signal. The operating signal of servo drive works with negative voltage. So the servo on signal must be negative. Our PLC outputs are positive, so we need to use a relay. We will receive a negative signal with the normally open contact of the relay. So Q0.3 or servo on signal. The stepper motor example, we will not use this signal, but we will use here this signal. And here our connection, and we know about connection. Now we start the project. I push create new project and name Servo Control, and I push create button. Okay, project view and device and controller. What I need S7-1200 DC and firmware version 4.2. Here is my CPU. I say OK. Okay, here our CPU. First of all, I need add technology objects. Add new object. I give name Servo 1, and I choose positioning axis, and I say OK. I have one technology objects, and this name Servo 1, and we know this parameter, and we can adjust again. I want to use degree and OK. Pulse train output and drive, we use pulse train output and pulse 1. Servo 1 pulse Q0.0, servo 1 direction Q0.1, enable output Q0.3, or we can use 0.2, no problem. I will use Q0.3. Here we pass Q0.2. Okay, here OK. And mechanics, here I will write 200 pulse per revolution, and this revolution give us 360 degree. I choose both directions, and I didn't say invert direction signal. Here is position limits. I will not use now this, and dynamics general. Here we can see how much pulse we can send in second. So I will not change this. This is enough for us. And this 5 seconds, I want to change this because this is a very long time. For example, 1 second is enough. Is emergency stop. I say 1 second. Okay, our system is ready now. After we make it connection, we will use this commissioning, and we will try our connections is right, everything is okay. After we will start our programming. Okay, let's start the connection. Here our servo motor, and here servo motor cable. Here and we say this connection color, and green color is 0.0, and here I connect it, and another one is yellow, this is 0.1, and another brown and white here, and this is negative voltage. Here is negative voltage, and Q0 0.0, Q 0.1 is ready now. I have red cable, this is 24 volts. Okay, and one more cable, this is blue, and this is servo on. We say we need one relay. Here we have one relay, and this have here normally open contact. So I will use this. What I need Q 0.31 cable, and this here A1 plus signal, and another here A2 negative signal. So when I activate or through 0.3, this relay will be activated, and this normally open contact will be start or will run. So I use this blue cable in normally open contact. And one more cable I need for connect my output, and the 0.3 output 0.3, here A1. And what I need two negative signal, one for relay, one for my common input. I have here one cable like this. I think this is enough for us. I will use white cable. And this negative signal or negative voltage for servo on and my relay. Okay, here is all relay connected. I will put here. Okay. Now everything is okay. Before here I have our encoder cable. You can see here servo motor have two cable. One is encoder cable, one is power cable. If you have this brake, this will be have one more cable, and this is brake cable. These motors don't have a cable because these don't have brake now. You can see here, and this everything is okay now. Our connections is finished, and we can try our software and after we will make one human machine interface and we will control our servo motor. Okay, everything ready now. You can see I make it some design here so we can see how much our motor move. And I will look online access and Realtek under Realtek Ethernet cards. So we will have connection or not connection. I will see now. And you see we don't have any connection. I check my cable. Okay. Update accessible device again. Okay, here our PLC one, and I want to delete everything inside because I make a lot of example every day. So this function reset factory settings, and I say reset. Now you can see our CPU blink is this LED, and now you can see orange LED. Now my CPU is stop mode and everything is delayed. So I can do land to device hardware and software change. We don't have any program now. I will try commissioning and I will check all my cable and I will check all everything. And if everything is right, we will start the program. Here my PLC, and I say load. Still my CPU stop mode. And here loading everything. This time we can, I think something wrong. I will try. Okay, everything is okay now. I say finish and go online and try to commissioning. We know how we use this. I must say activate and I must say yes. And I will close this window. I want to show you video. Here close. We cannot close this top button. If we close this top button, this quickly close or connection. I say enable, and you can see here our relay is activate now. When I say disable, you see our relay is deactivate and our servo is servo off. I push enable, my enable signal is coming now, my servo is ready. Here is velocity, jog position and velocity. If you want, we can check our speed, configuration, and dynamics general. We can write 1000, and we can write here 1800 degree second, or here 45,000 degree second. So we can write 2000. Here I come, and again enable. I must see all the signal. Okay, drive enable, my relay is now on and everything is ready. I can use jog forward. I will write velocity 200 degree in second. You can see very high speed, and now I will write little forward. This is very high speed, I think. Okay, anyway, we can change this. How we can change this? I want to make speed slow. My minimum speed 1800 degree in seconds. How I change? I come here. I will write here 100 pulse in second, and this here you can see, and I can write here 200, and this is like this. I can say more little, and I will write this here 5 pulse seconds, and here I will 360 pulse in second. We can write here 1 or 2 pulse in second, and you can see here. And when you change something in this technology object, I all time factory reset. I make all time factory reset because I have some problem before. When I make this factory reset, everything is okay, but sometimes I have problem if I don't make factory reset. When you change something is technology object. When you change your project, all your project, you can make this factory reset, and everything will be delayed. After you can use your system is nicely or correctly. I try again Dolant, and everything is okay now. Our speed is slowly than before. Again, commissioning. I will close all this screen. A little bit bigger. Now I push enable. Here we can see our relay is ready. Everything is okay now. We can use speed. I think 10 degrees second. I will check my camera now. Okay, let's try here our system. I will make forward. Okay, forward. Add a little bit more speed. Forward. Yes, this speed is okay for us. Okay, I want to bake a little bit. And backward. So we can come here and we can say set home position. Now here is our position is 0.0 degree, and here we can write travel position and 1 degree and relative 1 degree 1 degree. And okay, I want to now set home position because we see this line, this whole line 45 degree, so we can try this positioning. So I will say 45 degree and move obsolete. Okay, this is okay, but camera is, how I make it this. Yes. Thing like this, more height I must make. Okay, anyway, I will try now absolute. If I push absolute again, this will not move, we know this. I push relative, this go 45 again, this go 45 again, this go 45 again, this go 45 again, and now the same position, and this come 360 degree now. So our system is work, everything is work now, and we can write our program, and I will check this camera position, and after we will continue. Camera position okay now. I check it this, and we can use our system here. I will push here. Okay, now we can write our program. Before we use the same command, I say yes, and I come main organization block, and I must use technology, and here technology object and motion controller. First of all, I need a power. I put here power, and this is my power, and axis I will choose my axis, and I need enable signal. If you want, we can use again this data block system. So I want you to learn data block, and I write here dB or servo dB. You can write name what you want. Okay, I need power signal, power servo, and this will be bool. Yeah, I will use it like this, and I need here, and this is my power servo. If you want, we can try this. I load program. And monitoring on. Okay, modify 1, and you can see here my relay active now, and modify 0, and where is my screen? Here you can see my relay is off now and my servo is off. So power is work now. Another command I need, and go offline, and I don't need reset, I need a home position. Here I need choose my axis servo 1, and this execute signal, set home position, again bool. If you want, we can write here something, and we can write position, but I will not use this. Maybe after I can show you. And we need halt, and I choose servo 1, and this stop all I put here. Another one I need move isolate, and I say OK, and I choose axis servo 1, move obsolete, like this, move obsolete, and we need obsolete position. This must be real. Here obsolete position. I will use one velocity for all. Velocity is real, and here move relative I put here. Choose axis, and here move relative. This must be bool signal. I choose data type bool, and here, and relative distance or relative position. This must be real. I said I will use one velocity here, my velocity here. Okay, we can use move jog command. Choose servo 1, and this is forward jog button, jog forward, and this is bool, jog reverse. This must be bool. I need two signal here, and velocity is the same velocity everywhere, and jog forward and jog reverse. So this everything is okay now. One more thing I need, position. I need position, and this position must be real. Okay, here I'll use move command. I need servo 1 position, yes, and this servo 1 position and my position. So everything is ready now. We can try our software. I come here and do launch our software. Say load. Okay, I will try to minimize this screen. video, and monitoring on. So first of all, we need, here we can see our position now. First of all, we need servo on. So I modify this signal. My relay is active, my servo is activate now. Second, I want to make home position, modify 1, and my position must be 0 now. We can check it here. Our position is 0 now, and I must give velocity, and I give velocity is 5. I think this is okay, and position is 45 degree, and I try modify 1, and this go 45 degree, and if I want modify operand, and I want the 360 degree, so I want to come the same position 1. You can see here this come and this come, and this will be 0 position. It is same 0 position. Here we can see our degree. Anytime if I want to stop this, I can use, I will stop this, I can use stop all. I say stop all, and you can see our servo is closed now. Every movement is stop, and here we can try to move again. What happened we can see. Please go, and our position is here now. We need more speed. Okay, you can see this come here. I will give more speed. -20 in seconds, and I say modify operand 0. This will turn back, and this will come 0 position. My motor will come 0 position. Yes, this speed is enough. You can see here our pulse signal is come. This is our pulse signal, and if I say move another side, you will see I say this modify operand 90 degree and modify 1. You can see our direction signal is coming now because our motor turned another side, and still this come. You can see this here. So if I say modify and go 0, and this direction signal will be off. You can see now. You see, direction signal is go, and my pulse is come, and my motor is now is 0 position. So our program is work. Before we say this, positioning is very easy as S7-1200 systems. So here we can make it operator panel, and we can use this system with operator panel. See you next video.
Okay, we need to add some parts in our system. First part is here. This is a schematic net industrial switch. You can use normal switch, no problem. And this here we need to connect in power. This switch works 24 volt DC, so I will connect this. Another is here, or operator panel, and this needs 24 volts, and this must be connected with Profinet. And here you can see 4 ports have. One port is our CPU, one port is our PLC, and one port is our human machine interface. So we will connect all of them. So first of all, I need here put my switch, and I need 24 volts. This is positive 24 volts, and this is negative. And I will close electric now. Turn off power. Here I have 24 volts, so this cable is enough for me. I can use here 2 cable, another one for HMI. This is 24 volts. This is for our human machine interface. And here okay, yes, and another one negative voltage. And here I have negative voltage. Okay, this is okay now, and I need one more Ethernet cable. This is one. I will take off this switch here. This is first, and this will go for HMI. It's okay, and this another one come from our PLC here, and this another one is for computer or system. So I will put it in here. Okay. Now everything is okay. We can give power. Our switch is now okay, and you can see here two system is connected, and here our operator panel is work, and another I will connect Ethernet in my computer. Okay, you can see here I have three signals because we connect three Ethernet cable, and here is our operator panel. This start and transfer and start. We will transfer our program in here. I choose transfer. You can see here this now proficient and waiting for transfer. And settings, here settings, and we need network interface and network interface, and this you can see here address like this 0.2. this is, we must know this 0.2 close. Okay, and this will be wait for transfer. Yes, please wait transfer. Okay, let's make our program. Okay, we have now our operator panel, and we must add device, but first of all I try to look which one device we have. Accessible device, here you can see we have now HMI 1, and I want the command C. This is semantic HMI, and device name, this functions, IP address, and reset to factory address. So I need the add new device. Now I come HMI and semantic, got KTP 400, and I want to look this, which one is this two, and here our screen is here. I don't know which version I will use this. Okay, now I say okay, and here is wizard. I choose my CPU, I say next. I will not use header, and next. I don't want alarm, 1 second is enough now, and I don't want button, and finish. Okay, here we have operator panel. This text I don't need, so we can see here our system is waiting, and I will start the transfer for before we need the design. And here is root screen, is first screen. What we need first of all our servo power on or off. So I can use this switch. Here, first of all, we can use a text. Text is servo on and servo off. Okay, here we have switch, and we must choose our tag. This is very easy because we write all tags in one data block, so you can make your program part of part, and if you come here and you can quickly find which one tag, where is tag, which one tag you want to find. This is very quickly, and this is servo DB, and I need power servo. Here my power servo. This is switch on off, and another what I need one value, and this is my position. position, I want like this, enough for us. Can write here position. Okay. And what we need one button here. I will say move obsolete. Move a obsolete. Okay, I want edit bit. These have one another function. You can see here set bit while OK press it. Before we use another screen, and this screen didn't have this function. This is a very good function, and we can use this. And here move ABC, move obsolete. Okay, and we need here one more value. This is velocity. Here I will choose velocity, and this is enough for us. Alright, velocity. Okay, this is our velocity. Move move obsolete, and one more we need here. This is move relative. Once press, we need move relative. Two more need. This is obsolete position. I make copy paste, and this is relative positions. Here we can relative distance or positions. Okay, if we want, we can use jog command. Okay, here we can put 2, and this is jog forward. And I want press edit bits, set bit while OK press it, and we need jog forward, another one here, and this function, the function is move reverse, and properties jog reverse. So everything is okay now. We can see position, we can give velocity, we can make servo on off, and we can say move ABC, move relative, and one more we can use home and halt. Yes, this is homing, or set home. Another one is halt, stop.
Our screen is ready, and we can try to simulate. Here, our system here. You can see the servo on and servo off. We can see here green LED, and we can jog forward our system or jog reverse. We don't have velocity, we must give velocity 10 and jog forward. You can see our motor is working now. Jog reverse and move offset we cannot use because our home is not yet. Reverse, 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 forward 2 degree, 1 degree, we say set home, and now we can say 45 degree, move ABC or move obsolete, and let's go this 45 degree. Okay, our operator panel work now. We will try to download this or operator panel. And I say start search. I don't know this version, and this will come, and I say okay, I say load. Fit, overwrite all. And you can see here starts sending a system. If first will be update device firmware. After this will send our program. So this will be maybe 2 or 3 seconds. 2 or 3 minutes. I will wait this. After we will try this HMI software. See you next video. Okay, our system is ready now. We load HMI program, so we can control our system. You can see here servo on, and here you can see our relay is off now, and I can say on, and my relay on now, and I can say jog forward. You can see here jog forward and jog reverse. Here you can see position 360. I say move ABC, and I think we need home position, jog reverse, and this is enough. I say set home position and move ABC, move obsolete, and this go 360. Move relative, I can write here move relative 45 degree, and move relative, move relative, move relative, move relative. I will write here more 900 degree, and I say move ABC. At the same time stop. You can see this stop, and again I say move ABC, move obsolete, and I say go 0 position, and I change my speed 100 degrees second, and I say move ABC, move obsolete. Please go and 0.
servo off and servo on. The system works like this. Here we have Panasonic servo, and here we have HMI. Here have S7-1200 CPU, and here have one relay. So we control it. We can control our servo motor position. This is very quickly and very easy operation. We say again S7-1200 CPU or S7-1200 systems is very good for control servo motor position. Next course, if you like this course, next course we will control more than one servo system, and we will try to teach you another command. See you next course.